So let us see now the addition of vector. So when we say addition of vector, it means we are supposed to find the resultant of two vectors. So let us say we have the vectors A and we have another vector as B. Now we have 1 to add these two vectors. When we say we have to add these two vectors, so it means it is not to be algebraically, it is not to be added, because algebraically we can add or subtract only scalars. But when it is a case of addition of two vectors, it means it has to consider the vector addition. So when the representation as far as the addition is concerned, we will have this vector A plus this vector B. Now, when we consider vector A plus B, so we can have various orientation. Whether you write vector A plus B or you write vector B plus A, it hardly makes any difference. So we can write a plus vector A plus vector B or vector B plus A. And suppose we have vector D plus E plus M that can be considered, that can be expanded as vector D plus vector E plus F. Either we add this E plus F first, then this D or D plus E first, and then that F. It hardly makes any difference. So these are some of the properties of the vector position now. How to add these vectors. As far as the vector additions are concerned, there are certain prerequisites. Let us see as it is reflected here. This is your vector E and this is vector B, head of the first vector. Now we are talking this dramatically, how we can add it head of the first vector. If it is joined with the tail of the second vector, this is your vector V. If you call it as second vector, and this is vector A, so head of the first vector, this is vector A, and this is the tail of the second vector. If these 2 points are joined together, then join the tail of the first vector with the head of second vector. That lines gives you the resultant of these two vectors, the resultant of this vector A and B. I will elaborate it further. Let us say you have this vector, suppose like this, the first vector, second vector is, suppose you have this B. So head of the first vector, it is joined with the tail of the second vector, tail of the second vector. Then join the tail of the first vector with the head of the second vector. So we have this one. Suppose we get a third vector C. After adding this vector A and B, we get a third vector C. So this C is represented joining the tail of the first with the head of the second. Then we say that vector C, it is equal to your vector A plus vector B. This is the condition that head of the first vector, it should be joined with the tail of the second vector. Then join the tail of the first vector with the head of the second vector. That line gives the result end of the vector. So if it is suppose C, so we write vector C squared to vector A plus vector. Now here, suppose you have vector A like this and vector B like this. Okay, now, here, tail of the first, it is joined with the tail of the second. So we will not say that this is the vectors joining the head of the first with the head of the second. So this is wrong representation. Always, that condition has to be satisfied. Now that condition, that head of the first, it should be joined with the tail that is required. That is necessary so that we can take proper care of the sign convention. And the sign convention is angles are always measured in the anti-clockwise direction and measure in the anti-clockwise direction. So here, if you consider this as far as the measurement of this is concerned, suppose this is your x-axis and this is y-axis. Angles are always measured, let us say theta, in the anti-clockwise direction. If you say angle between the vectors A and B theta, so angle between the vectors A, let us say this is A and this is B. Okay, so angle between the vectors A and B. When we say this statement, A and B means from A towards B when we say B, and A means from B towards A. So angle between A and B. If it is theta, it should be from A to B in the anti-clockwise direction. That is the convention that we always follow if angles are to be measured. So it is always considered in the anti-clockwise direction with respect to the first vector and the second vector. Between A and B means from A towards B in the anti-clockwise direction. So here, if this angle is theta, then we will take this angle as theta. So this is A and B. So always in the anti-clockwise direction with respect to the first vector. When we say first vector, so here if it is A and B, then it will be A will be treated as the first vector, B as the second vector. So like this. So here, if you consider, suppose vector along x-axis, let us say this, and this is your vector b. So from A towards B in the empty clockwise direction, with respect to what? Positive x-axis. So this is your positive x-axis. This side, it is negative. You can decide positive y-axis. This side, it is negative. With respect to positive x-axis. This is clear. So always we can consider this. We can also consider this as your x-axis. X and y-axis are what? X and y-axis are nothing but the two lines which are mutually perpendicular to each other. If you consider this line as the x-axis, then the line perpendicular to this will be considered as the y-axis. If you consider this as the x-axis, then the line perpendicular to this will be considered as the y-axis. So if I have taken here as this line, so it can be considered as the x-axis, then another line perpendicular to this will be considered as the y. This is your another vector, this b. Angles are always measured in the anti-clockwise direction with respect to qualitative and success, and it starts from the first to the second vector. So that way we consider this. Now, when I say the head of the first vector, it should be joined with the tail of the second vector. Then join the head of the two vector, then the tail of the first with the head of second. That line always gives the resultant of the vector. So this is the convention, so that we can take care of the magnitude as well as take care of the directions properly, without any confusion or without making any mistakes. So here these are the different representations. Vector A, similarly, you have this vector B. So vector B, this side, if it is taken positive, so this side, it will be taken what? Negative, any minus of B. Negative means minus of B. That means in the opposite direction, so we have this minus B. Now this is your vector A and this is vector B. So this becomes what? A minus B. In fact, it is a plus B, but a plus opposite of B. So a plus opposite of B means what? Minus of B. And that's why here it is a minus. This is our A. No, sorry, B. So actually B is in this direction. So minus of B, it will be in this. Now we are adding what this line is parallel. This line is parallel to this. So we are making or adding A plus this vector, and this vector is not B. This vector is opposite to B, so it is minus of B. So this is also the resultant of the two vector. One vector is in the opposite direction of its actual direction. So these are the different representations. So you can see this, a minus B is nothing but a plus minus, or B means if you have to subtract the two vectors, so make the second vector in the opposite direction, and that become the addition of the vector. So addition or subtraction, they are almost same thing. Only thing is the vector has to be taken in the opposite direction of its real direction. Now, before we consider this addition of the vector further, because we will need resolution of the vector, just to simplify, just to have more elaboration, as far as the addition of vector is concerned, we need the resolution of vectors. So let us consider this resolution. Resolution of vector means finding the component. When we consider addition of vector means finding the resultant of the vector. So similarly, the resolution of the vector means finding the components of the vectors. So suppose we have this vector E, okay, and A is making some angle theta with the x-axis. So the direction of A is theta with respect to positive x-axis. Now this vector A is having some magnitude, it has this direction, and that direction is theta with respect to positive x-axis. So it will have its value along x-axis, and it will have its magnitude along x-axis as well as magnitude along y-axis. Direction will remain same. That is theta. So what are those values? So drop a perpendicular line from here on the x-axis as well as on the y-axis. This part will be considered as the magnitude of this vector A along x-axis, and this part will be considered as the magnitude of this vector A along them. So this x, if we represent this part as x and this part as I, then x and AY. It will be termed as the components of the vector, we say. X and AY are the components of the vector A, where A is the resultant of these, with x as well as this A by component of a vector. It is a scalar quantity because when we consider this ax, so we are just considering the magnitude. Part of this, the value of this, a magnitude of this, along the magnitude of along this. So that becomes the component of the vector. It is a scalar quantity because we are just interested in the magnitude part of this. Again, if you say that this component is along x-axis, then again we are changing that scalar to a vector quantity because we are defining its direction that this is along x-axis. So in that world, it becomes a vector quantity. Otherwise, when we are dissoluting this vector A, when we are finding the component of this A, we are just finding the magnitude part of that along x-axis as well as y-axis, or in general, around any two mutually perpendicular lines. Components of any vector quantity, it can be calculated along two mutually perpendicular lines in general. X and y axis are nothing but two mutually perpendicular lines. It can be represented like this and like this. It can be represented like this and this. This is your x-axis and this will be y, provided this angle is 90 degrees. So it can be around any two mutually perpendicular lines. Now here, so how to calculate the value of this x as well as ey? So when we have dropped this perpendicular, so obviously this is a right-angled triangle. Now, if this angle is supposed theta, then cos theta in this triangle, cos theta in this right-angled triangle, that will be equal to how much you can consider cos theta is equal to. Based upon hypotenuse, so this is how much x we have assumed that a of hypotenuse is a. When we say a, we are talking only on the magnitude part of this vector a, so based upon hypotenuse, so x upon this thing. So from here, you can calculate this x is equal to a cos theta. Similarly, if you consider sin theta, so if we consider sin theta here, then sin theta is what perpendicular upon hypotenuse. Then this side divided by this side, so this side is how much a, so that becomes so divided upon this a. So again, from here, I, it is equal to how much? Vicinity. So x component is your a cos theta, and y component is a sin theta. So this is a just using the concept of the right angle triangle. Cos theta is based upon hypotenuse. From there, you will get a cos theta. Sin theta is perpendicular upon hypotenuse. You will get this. Ay is equal to a sin theta just using this calculation. So using that, so we can calculate the various components of the vector along x-axis and y-axis, you might as well as this. So these are termed as the components of the vector. And this process of finding the component of the vector that is termed as the resolution of the vector. So here you can see a x equal to a cos theta, a y is equal to e sin theta. These are supposed to be, in general, scalar quantity because this represents only the magnitude. Here also, when we have written this a, we are not putting any vector notation. We are only taking the magnitude part of this vector a. I hope this is clear. Now, if you want to find the resultant again, if x and I are known, then resultant will be what? This is a right-angled triangle. So you can use the Pythagorean's theorem, x squared plus ay squared square root, that gives you a. If this is square plus, this is square root, we get this a. So x squared plus ay squared, that is a. So again, it gives you the magnitude of that vector is. Now, what is the direction? If you want to calculate this angle theta, how to calculate theta? So tan theta is equal to how much? Tan theta is this component upon this component. So using that concept, we can calculate this angle theta. So tan theta that you can see here is equal to y component divided by x component. So tan theta is equal to ay upon x magnitude, the direction of this a. If you want to calculate tan theta. And once you calculate tan theta, you will get the direction theta is equal to 10. Inverse y upon this ax. Similarly, the magnitude square root of x squared plus ay squared is 1. And that way we can calculate, so from resolution to the resultant of the vector, and from resultant to the resolution, so we can analyze this. So here you can clearly see on this particular screen now. What is the advantage of resulting a vector? Because when you consider the vector addition, when we want to calculate the resultant, let us say vector C is equal to vector A plus vector B. We cannot have, other than this symbolic addition or symbolic representation, we cannot have the vector addition. So what to do? Find the resolution, find components of the vectors around x-axis, y-axis. If it is three-dimensional, then around z-axis also x-axis, y-axis, and z-axis. If it is two-dimensional, find components along x and y. Now, if you find this, if you suppose this is a symbolic representation of this now, Cx. Cx is suppose the x component resultant of the x component of the vector, and Cy is the resultant of y component of the vector. Let us say so here. This is equal to how much ax, and this is equal to how much a1. Just now we have calculated, so Cx is square plus Cy square square root. That gives us what the magnitude of this vector C, magnitude of this vector C, that will be equal to your Cx is 1 plus Cy square square and Cx square. To how much x and Cy square to home to a. By simply price of find the component of the vector and using the simple algebraic calculation of finding the resultant of the quantities. We have the square root of Cx1 plus psi square C. This vector C, if a resultant of this vector C, suppose this A and B, if it makes angle theta, if it makes angle theta with the x-axis, I am not talking of the vector A and B, if the resultant of the vector A and B. If it makes angle theta with the x, then what will be the direction of that C? If it is, suppose theta, that tan theta. It will be equal to how much y component are divided by x component, means y component upon x component, and here, y component is common A, and x component is here. So that way we can calculate this step. It's good. So this here, we have taken only two vectors, vector A and vector B. If there are, suppose any number of vector A, vector B, vector C, vector D, and so on. So the resultant R, it will be equal to how much? If it is suppose resultant R in general, then it will be equal to how much? Vector A plus, vector B plus, vector C plus, vector D, and so on. So this is the vector addition. Direction of this R, so direction of this R, if it is theta, direction of the resultant vector. If it is suppose theta, then tan theta. It will be equal to how much summation of y component of all the vector divided by summation of x component of all the vector. Now here all these vectors will have the x components as here we have seen. In case of only two vector, we have the component of A, we have component of B, so ax as well as a1. Now, if you are having, suppose, many more vector source, which tend to be calculated, which are supposed to be added, then we will have x component of this, y component, x component of this, similarly this, and so on, and y component this. When we calculated x component of all the vectors, so they are what is scalar. So they can be added algebraically. Y component of all the vectors, they are also scalar. So it means, again, they can be added algebraically. So we have this x of this plus bx of this, cx, dx, and so on. So we can add them. So that becomes what summation of this x. Similarly, y component of all these vectors. So that will be called your addition or summation of that once you know. The summation of all the vectors along y-axis, summation of all the vectors along x-axis, or the magnitude of all those vectors. Then tan theta the region, and that the resultant of these vectors that makes angle theta with the x-axis. That will be nothing but sum of all the components along y-axis divided by sum of all components along x, and the resultant value, the magnitude of this r. If you want to calculate magnitude of this r, that will be how much? All the x components are known to us. All the y components are known to us. Summation of this x square plus summation of y square is square root. So this gives you the result. So now let me summarize. Whether it is a case of addition of two vectors or any number of vectors, calculate the x component of all the vectors. Calculate y components of all the vectors, summation of x, summation of y resultant, any magnitude of the resultant of the vector. It will be summation of x square plus summation of y square is very direction of the resultant. If it makes angle, suppose theta with the x-axis, then tan theta of that, it will be summation of y divided by summation. This is the simplest way to find the resultant of any number of axioms. So it means the retribution of vectors are needed so that we can convert the vector, as far as the magnitude part is concerned, in the scalar form. And once we have that scalar quantity as the magnitude, we can simply use the concept of this algebraic addition, and we can calculate whatever is required. So now we can again continue with the addition of the vector. So here in this diagram, you can see we have the vector A, there is another vector B, an angle between the vectors A and B, it is theta. Now, so this is the head of the first vector, this is the tail of the second vector. Here you can see this is vector A and this is vector B. This side is the head of the vector B, this side is the head of the vector A. Now we have joined the tail of the first vector with the head of second vector. So this gives us the resultant of the vector A and B, and that is suppose C. So we have the vector C as the resultant, or the addition of the two vectors A and B. So C is equal to a plus B. Now when we consider this equation, vector C is equal to vector A plus vector B. So this is the vector equation. When we say vector equation means the magnitude of the resultant vector is C. So magnitude of the resultant vector C, as well as the direction of the vector C, both are included as far as this equation is concerned. So the only thing is we have to always consider the condition as far as geometrical representation is concerned. You have to consider this condition. That head of the first vector, it should be joined with the tail of second vector, then join the tail of post. With the head of second, you get the resultant of the vector, that is the P. Requires it of the basic relation. And why we do this, why we require this, that we have discussed that angles are always measured in the anti-clockwise direction with respect to positive x-axis. So here angle between A and B, it is theta. So when we say angle between A and B is theta, so we have not taken this angle as theta. Because here, if you take this angle as theta, let us say from A to B, angle between A and B. So when we say A and B, so it should always be measured from A towards B. So if I take this angle as theta between A and B, that means we are proceeding in which direction? In the clockwise direction. But the standard convention says it should be taken in the anti-clockwise direction with respect to positive x-axis. So here you can see, say that this is the vector A and this is vector B. Why we are taking this angle theta? Because just to meet the required condition. This point of intersection will always be considered as an origin. So if you take this as origin, so with respect to this, we can consider this extended line so that with respect to this origin, this becomes a positive x-axis. Now this line and this line, it is parallel. So we say angle between A and B theta, or angle between this line and this line theta. It becomes C because this line and this line, they are parallel or coinciding lines. Now, positive x-axis in the anti-clockwise direction. So we have now created this positive x-axis, taking this as the origin from A towards B. So now I am taking from A. This line is parallel to this. That's why either you say from a this or from a this in the anti-clockwise direction. So in the anti-clockwise direction from A to B, so this becomes your theta. That is why we have considered this angle as theta, not this angle as theta. Because here it is measured in the clockwise direction when we read it at A to B. When A to B, we proceed in this direction, so this becomes your anti-clockwise direction. This is the point of origin. So this becomes positive at Celsius. It means all the conditions are satisfied. So we have to meet the condition, and then only we can measure this angle theta. I hope this is clear. Now, so now vector A is here, vector B is here. This angle is theta between A and B. Now we have this resultant vector, this C. So let us calculate. So we have this vector equation, vector C is equal to vector A plus B. Now, one by one, we will calculate the magnitude of this vector C, as well as the direction of the resultant vector, the direction that it will make with that. X-axis, that is a standard convention. Generally, when we calculate the direction, so we try to define in terms of x-axis, We can define in terms of y-axis also, in z-axis also. But we have to specifically mention what is the direction with respect to what axis. So here, just to calculate the magnitude of this vector, see now, we will resolute the vector. Just now we have seen how to resolute the vector to drop a perpendicular from here. Okay, now this is B. It makes angle theta with this axis. So again, taking this cos theta here, cos theta is called homogen, based upon hypotenuse. So this part, if it is supposed f, then that x or bx, this part is supposed this bx, so this bx that we can calculate using the cosine relation cos theta based upon hypotenuse. So this gives you bx is equal to b cos theta. So bx is equal to b cos theta. Similarly, this is supposed by. So by means y component of this along this y-axis, because this line is parallel to this. So that will be how much? B sin theta. So already we have discussed all this. And again, if you have any confusion, you can just consider this as right angle triangle cos theta. You can consider this side upon this side. Sin theta, you can consider this side upon this side. So from there we can calculate bx as well as by, so by it will be equal to your b sin. Okay, so this is b cos theta, this is b sin theta. So this part now we have known. We are having this part as bx and this part as by. Now here you can see I have not put vector rotations here because we are just interested in the magnitude part of this, because we want to calculate the magnitude of this resultant vector c. So bx is a component which we have already said. It is a scalar quantity b here, and only taking this magnitude part of this b, so b cos theta here also is b sin theta. So this part, this total length becomes how much? A plus bx, okay? And this length becomes how much? By now, again, this is a right angle change. This bigger triangle, it is also a right angle triangle. So in this right angle triangle, using the Pythagoras theorem, this square is equal to how much this is square plus this is square. And from there, we can calculate the magnitude of that. So can you say that c square. Again, I am not taking this vector notation as far as c is concerned. Now I am only tracing the magnitude. Part of is this vector. So c square, it will be equal to your, we are looking at the expression a plus b times x all squared, which is then added to this v divided by the quantity a plus b times x. This total length is a plus bx, again, the magnitude of a, and this bx, so a plus bx, so a plus bx plus this v by square. So from this, you can calculate c square is equal to a plus bx, a plus bx, bx is on which b cos theta. Plus this. So this expression will be equal to a square plus b square cos square theta plus twice of a b cos theta. So we have a square plus b square cos square theta plus 2ab cos. And then for the term b sin a theta whole square, this means we have b square sin a square.